Today we will be taking notes about Earth's atmosphere. Be sure to have your note sheet available in front of you. Your job is to fill in the red words as well as any drawings you're told to fill in. We're going to look at answering the question, why is the atmosphere so important? Why do we care about it? In order to answer that, we need to know what the atmosphere is. The atmosphere is a thin layer of gases, which make up air, surrounding Earth. Gravity pulls it to Earth. It extends from Earth's surface, where you and I are walking around, to outer space. Right now, please color in the small picture at the top of your notes to show the atmosphere. So, what's in it? Earth's atmosphere is a mixture of a variety of gases. Water vapor. This makes the weather, like clouds and precipitation. And dust. So you have a circle on your notes, and this shows the percentages of what the gases are. It does not include the water vapor that's also mixed in the atmosphere. Right now, please divide up the circle in your notes and label the amounts of nitrogen, oxygen, and other gases. Pause here as needed. So what does the atmosphere do? What does it do for us? Earth's atmosphere provides us with a balance between the amount of heat absorbed from the sun and the amount of heat that escapes back into outer space. This reminds me of Goldilocks and the Three Bears, about how her porridge was too hot, too cold, or just right. Our atmosphere keeps us just right. Just the right amount of sun energy reaches us here down on Earth's surface. So our notes, we want to say it stabilizes the temperature for life on Earth. If we weren't at this perfect balanced temperature, life would not be possible. It also protects us from, and other life forms, from meteors and from the sun's harmful UV rays. UV meaning the ultraviolet rays. Very much of the sun's UV rays actually bounce off the atmosphere and get reflected back into outer space. So we are receiving just the right amount. Our atmosphere is made of 5 layers. You only need to write the names of the layers right now. We will take more notes about the facts about each layer in the future. We start at the bottom closest to Earth. This is the troposphere. We live here. All weather happens here. And Mount Everest is just below the top of this layer. So all of our land is even within this layer. The next layer up is the stratosphere. Sometimes planes will go up this high and fly here because they get to be above the weather. This is also where we find the ozone layer, and that protects us from a lot of those sun's harmful rays we talked about. Above that is the mesosphere. This is where meteors burn up. So when they get a little too close to Earth, these meteors are flying through space. It's the friction against the super cold air here that burn up these meteors. It's a very cold layer. Next is the thermosphere. As you can tell by the name, it is very hot here. You will also see the northern lights, and things like the International Space Station can orbit here. There's still enough of Earth's gravity to keep it in orbit around Earth, but it also has so little gravity that an astronaut kind of floats around up there. Finally is the exosphere. Some satellites also orbit here, the ones that are responsible for TV and radio waves. This is really kind of a fuzzy area. It's the boundary between what's considered within Earth's orbit and outer space. So far, your notes should be completed. On the left side, pause here as needed to fill in anything you might have missed. We're going to continue on. We're going to look back at what we already know about molecules in the atmosphere. We need to know what happens to these molecules as they move through the atmosphere, and we already know that molecules are always moving. We know that heat causes the molecules to move faster, and it also causes molecules to rise. Cooler molecules are heavier and slower than the warmer molecules, so they will tend to sink. So now we're going to look at the molecules in the atmosphere, in the air. We also need to know the word density. That means how close together the molecules are. Look at this sponge and this brick. They are roughly the same size. But if you've ever held either one of these, you know that the sponge is much lighter than the brick. And that is because of density, how tightly packed the molecules that make them are. There are many, many, many more molecules inside this brick than there are inside the sponge. So because there is less molecules, they're more spread out. They take up the same amount of space, but it's not as heavy. Now let's apply this idea to air. Air pressure is the downward push, and as you go, it decreases as you go higher into the atmosphere. So let's take a look at what this looks like. If I am standing at the bottom of a mountain, an air column would be all the air molecules that are directly above my head. And if I were to climb up to the top of that mountain, an air column would be all the molecules above my head. But notice that as I went higher, there are less air molecules above my head. So air pressure decreases, so the amount of downward push on my head decreases if I am up at a higher altitude. When I'm at a low altitude, I have a lot of air directly above my head pushing down on me. This idea is important to know as we get into our next topic. So we're going to do a little recap here. The closer you are to the Earth's surface, the more dense the molecules are. This makes sense because we know gravity is pulling all of the molecules down here. So if I'm standing down here, the air is very thick and dense because the gravity is pulling all these molecules down. Please fill in your diagram. So you're going to start with your squares, showing how the density of the air molecules decreases as you go higher in the atmosphere. And then I want you to fill in your labels for close to Earth and far from Earth. Pause as needed. Okay, so our big topic now is going to be going into wind. How does this idea we just talked about relate to wind? First of all, this is the start of movement of air. The sun's radiation heats up Earth's surface. We know that. So we're following this little line down here. Sun is heating up Earth. The hot ground touches the air nearby. So, that's really warm. And it's going to make that air start to rise. Now, when that rising air moves away from the hot land, it's starting to cool off. So it kind of floats away and cools off. And what do cold things do? They sink back down. So let's look at what wind is. Wind is air that moves from high to low pressure. So that creates the wind. If you have a big difference between pressure, that means wind will blow faster. Changes in air pressure tell us when there's going to be a change in weather. So if we look at this diagram, we can see there's an area over here in the shadows of the clouds, and that makes the air a little cooler. So air is going to sink here. Air will travel across the Earth's surface, moving towards an area that's warmer. When it reaches that warmer area, it heats up. And we know convection, we know hot air is going to start to rise. So this is just the very beginning introduction to wind. We will get more detail in the future. But so far, the right side of your notes should look like this. And on my next screen, I have the completed notes. Be sure you've paused here and have all of your notes filled in. Thank you.